VEX time. So this is the daunting language of VEX that I'm going to be talking about in this tutorial. So a lot of this is going to be points that we're going to have to look at in this tutorial. So I'm going to be hiding stuff. So we can't see the origin, we can't see the grids, and I'm going to make the background black. Very scary. We're in the abyss now. But trust me, we're in the center. If you get lost, just click H and we'll be back to our center point. So I'm going to create a geometry node, and then I'm going to put down a grid. And now we see a grid. So we're not alone now. And then I'm going to put down a point wrangle. Now let me just discuss data types. So if I go into our geometry spreadsheet, which is a new concept to us, and what we've got over here are point attributes, vertices, which I'm not going to be touching on, and primitives. So basically, it will show you every single point, in this case, every single point in this list, and it will show the attribute and then the value that's set on that point. So it's showing us that 0 is set to -5 on px. Then we have primitives. You can transfer these attributes between primitives and points, which is useful in a number of scenarios, by using attribute at promote like that. And then this allows us to take something from a primitive and put it into a point, or vice versa. And we also have up here, we can change these into a primitive VOP, a point VOP, which we're on currently, or vertices and numbers. The way that we will access an attribute is at followed by whatever the attribute is. So if I want to do at p, that's us got our at p attribute, and this being a vector, which is a data type, I'll show you the different types of attributes. So up here we've got a vector, which is a 2-float vector. And what I mean by 2-float is that each one of these values are floats. And the way that we can tell this is that if I do 10.5, this will increase. This is a float. And down here we've got integers. And I can do 10.1 and it won't do anything. It will round up, but it will always be a whole number. Always. And then here we've got a full vector, a full 3-float vector, which is what we're going to commonly see. A few things that are vectors are colors. So if I put down a color node, we can do all this in VEX, but we can set the color here. And the reason that it's a vector is because it's storing 3 values here, our R and our G and our B values. So if I do 0, 0, 1, we've got blue, green, you get the idea. Hopefully. And if we have a single float value, it could be our scale. So for example, if I put down our transform, we've got uniform scale, which is our float. And then we've got the size, or the scale, which is a vector. And we can transform this on different axes. God damn. But we can look and see what attributes we have here, and what we've got currently is P, but we also have a bunch of hidden attributes. So if I go and put down a point VOP, you can think of this as a visual representation of VEX. We've got all the attributes and we can alter them in whatever way we want. What we can do is we can set the position to the color, and if I plug these in and click R to make this viewable, you can see that it's setting the color to the position, which is pretty interesting. You can plug this into a noise. As you can see, that it needs a position, and then we plug our noise into our color, and since we've not got many points, it's not really creating a very complicated looking noise, but it is a noise nonetheless. And the main reason I brought you in here is because we've got all our attributes that are sort of preset, that we can actually access and create. So we've got position, and it tells you what the data type is. So we've got a vector here, we've got a vector for velocity. Let's find the float. We've got age, We've got ID, which is an integer. ID is really useful. ID and point number are essentially the same thing. So we can actually visualize point number. So as you can see, it's showing us sort of a gradient from 0 to 99, which is our number of points. And then if we go over here, we've got our number point, which is the max amount of points. So our num_pt is 99 because that's the highest number in our point number attribute. And this allows us to normalize it, which is a function that I'm going to be using quite a lot. So anyway, let's go and set this parameter inside of VEX. So normally what you're going to see is you're going to see at p, or whatever, at cd, at whatever attribute equals whatever value you want. So I'm going to put down 1. I click escape and it will run the code, and it's not working. Why is that? And it's because we haven't closed out our code, which you do with a semicolon. And now our code's run, and you might be like, where is it? Why isn't it moved up? Why isn't it changed? And what it's doing is it's setting every single point to 1. So if I put down a grid, you'll see that X, Y, and Z are all set to 1. If I go in my geometry spreadsheet to see each point, everything is set to 1. And if I wanted to add to this value instead, I could do at p equals at p dot at p plus 1, and this is going to add our value like this. So that's me just bypassing the node to see what it's doing. And a short form way of doing this, which is extremely useful, is doing what you want to do before the equals. So that's the exact same as, it's the exact same, does the exact same thing. But since we've already set it to 1, it's adding to it again, so that's why it's changing. And we can multiply, we can do dot, we can do an asterisk to multiply, we can do divide, we can do minus, and that's pretty much all you need to know about that. But there we go, we set it to 1 again. So there's 2 different ways of creating attributes. The first one I'm going to talk about is by doing it permanently with the at symbol. So we're just going to write at my attribute, and this is going to create a float by default. So that's us created an attribute. And it's not doing anything, so we've just created an attribute. It's not remapping anything, it's not changing anything. But by default, what this is doing is creating a float called my attribute, which equals 1. And if I go into our geometry spreadsheet, you can see that it's 1 over everything. It's just set to 1. And if I go over here and click, we can do middle click, which is a shortcut for this node info. It's created our attribute. We could also make sure this is a float by clicking F. So we've got F, which is float, and setting the float to my attribute, that's the name. So we've got the data type and then the float name. We can do V, which will create a vector, as you can see. We can do I, and I'll be including in the description with the relative or the related links. I'm going to be including the Houdini sort of article about creating attributes, because you can create, you know, like vector 4s and stuff like that if you want to. And again, when I was talking about vectors, we can access the different parts of vectors. So if I wanted to set the color to red, so let's say, I can do at cd equals set 101 100, sorry, escape. Now it's red. But what if I just wanted to access one of the floats inside our cd vector? I can do cd.r equals 1. Oh, everything equals 1, so what I can do is I can do at cd equals 0, and then I can set cd.r to 1, and that's going to set r to 1. Now, to create to create a non-permanent attribute, what we can do is we can do vector space, and so basically we do our data type. So we do vector space, whatever we want to call it. So color red. When you're creating an attribute, you cannot have spaces. You can have underscores, you can have numbers, but not spaces. And make sure you know that they're case sensitive. So when you were typing CD, if you weren't typing capital C followed by lowercase d, it won't work. So since a vector, we can do that. And you'd expect with a normal attribute to see this now, which we don't. Doesn't exist. It's only run within the code, which if you're running over millions of points or millions of particles, this can save a bit of time by not creating attributes. And then what we can do is we can reference this without using @. So when you create attributes this way, you do not need to add @ before your attribute name. It's just vector followed by the attribute name, and it's referenced the exact same way. So if I do @cd equals color red, close that, we've got red because we've set R to 1. We can set it to green, whatever we want. And editing things this way is a little bit annoying. So if I wanted, what I could do is I could create a channel. So in my last video when I was talking about relative references, you'll remember, or you might remember, that when I copy and paste something, in our expression we've got this channel, this ch before our node, and we can do the exact same thing inside of VEX. So let's set this to 0. So you can create a channel, and by default it's going to create a vector, a float. So ch, that's just creating a float. If I do chv, that's creating a vector. If I do chi, it creates a integer. chf, which is float. So yeah, let's create a vector and call it. You have to enclose the name. This is just a name. This can be anything. You can just do that, descriptive, I know. But basically once you do this, nothing's going to happen until you click over here, create spare parameters. As you can see, it's saying something about ch in brackets. That's what we've done. And now create a color. Very nice. And this is very useful to edit stuff afterwards. Right, so now that we've done that, let's talk about ptnum, which is another extremely useful attribute. If you want to delete any of these, by the way, you can go up here, click the cogwheel, edit parameter interface, and you can add floats into here and reference them if you want. So if you drag like a float over here, that's going to add a new float like that. So I'm just going to delete that, and then I click accept, and then there we go, it's all gone. So now let's talk about ptnum. Basically, if I do @pt, I want it to be it's going to set to an integer by default, but just to be proper, I'm going to set it myself. So what we're doing here is integer, then our name that we're creating, which is pt. This can be anything you want, and we're setting it to our point number. And when this runs, you're going to see that we've created our point number attribute here, and we can now see it. If I was to visualize the actual point number with Houdini, you can see that it's doing the same thing. It's creating some points all the way up until 99. Now, this is extremely useful for if I wanted to create a gradient, for example. But if I was to go and visualize this with CD, so if I wanted to do @cd equals @pt, it's way too bright because it's just going from 0 to 1, so instantly it's going to 1, and then all we're seeing is the brightest color ever. And also because it should be a float, we need to convert this value from an integer to a float and then remap it to our CD. Now, how do we normalize this? If you remember earlier, I was talking about number point, which is the max point in our list. which will change with how many points we add or whatever. It's always going to be the highest point, so it's always going to equal 99 in this case. So if I divide this by numpt, you can see nothing's happening. And the reason for that is because we still have an integer. So it's just going to be 0 all the way through. So what I need to do first is I need to change this to a float. So I click F, or you can just get rid of this altogether and it'll create a float. Or, I mean, you need to do that as well as you need to multiply this value by a float. So if I do that, just lay it out a bit nicer. Doesn't matter about the spaces, they are ignored. It's just sort of a visual thing. And now we've got a gradient from our first point to our last point over here. And I'll show you how to sort of use this in a more interesting way. Let's get a line here. And I want to plug this into our point attribute. And now we've got our gradient going from 0 to 1. And if I copy points onto this, so these are our points here, visualized. We've only got 2. Let's go and increase this value to 13. Put a sphere down, or whatever object you want to copy to these points, and put it into the primitive copy, the first input. Now, you can see that it's taking on the value of the color, which is interesting. But also what we can do is we can set this to p scale. So at p scale equals at pt. And now we've got this 0 to 1 scale on our p scale. Now what if I wanted to remap this value? So we can use the fit function, which is an extremely useful function. So I can do fit and then at pt, and then we do 0, 1, 0, 1. So what this is doing is these two values here are our source min and max values, and then this here is what we want to output, our resulting values, I guess. But currently it doesn't do anything because we're just, you know, it is currently 0 to 1 and it's being remapped to 0 to 1. So there we've set it to 3, so it's remapping this to 3, and we've got this weird looking ice cream cone or something. But we don't even need these first two values in most cases if we know that our attribute is normalized to 0 and 1. So I can get rid of this and put down fit 01, which is another function, and we did the same thing without that extra, those like four extra letters. So that's one way of remapping a value. Another way we can remap a value is we can remap it to a ramp. So what I can do is I can do the attribute, or the command, the function, sorry, shramp. So it's channel ramp. That's what that is. And we've got a little smiley face. So I'm going to create the name here. This can be anything, my ramp. And then we, after this, put down our attribute that we want to create a ramp out of. And it's not doing anything currently, and that's because we haven't clicked over here to create the ramp parameter. And here we go. Beautiful. We can create a ramp out of this value. And you can already see how this is going to be really powerful later down the line when we're doing more complicated stuff in modeling and whatnot. And also, if I want to ignore a line of code, I can create a comment out of it by doing //. But what comments are really made for is for doing explaining code. So I could do normalize our point number. And I forgot to mention, but probably a better way of doing this would be to set this value to not be permanent, like I was talking about earlier, by doing float pt, removing this @ sign because it's all just within this node, and that's how you reference non-permanent attributes, like I was saying. It does the same thing, but that PT value is not stored anymore. It's only going to be stored, or only these values with at in front of them are going to be stored, basically. So those are the main functions that I'm going to be using here, along with one more, which is, I'm just going to change this to @pt now, because I don't want to remap it, is randomize. So maybe we can make this a bit cleaner by doing a new attribute for this. We could actually do it up here, but it's just going to get a bit messy. So let's create a float pt rand, which is going to equal rand pt. Let's see if that works. There we go. So now we've randomized this value, and we can go in here and we can see that these are not in order like they would be initially. You can change the seed of this value as well by adding to it, or we can multiply it by a value as well. We can do 23. We change the seed of it there. You can even put a little value down so we don't have to go and type it every time. So now we're multiplying it by the seed. There we go, looking a bit crazy. So yeah, as you can see, a really powerful little tool set that we've got already, and we've not even got into the heat of it with VEX. So yeah, this should set us up nicely for using VEX in our later tutorials. I hope you guys enjoyed. If you have any questions, just put them in the comments and I'll try and get to them. And I'll see you in the next video.